Start to record. Uh, I just forgot to adjust my speaker. I thought someone was speaking. If there is a question, you can ask. Please ask again. I forgot to hold my microphone. Should we start the third part? Just a minute, someone. Yes, yes. All right. Let's start the last part of our today's session. It is about box plotting. There are a lot of more options in the graphical mode, but the box plotting is very important. So we will discuss it as the last part of today's session. That was the drill I have given to you. Hope you have done it. You can submit your results, whatever you have done with the bar charts or line charts or pie charts. You can submit it directly to the WhatsApp group. Let's start for the one of the important element of graphical representation of data, that is box plotting. Box plotting, we will discuss box plotting with its different types, which data requires it and why we prepare it. And we will also discuss the drill number 3 regarding the box plotting of your data, and you will be given 10 minutes. So what is box plotting? First, you need to have some idea about box plotting. A box plot, also known as box and whisker plot, is a statistical visualization that provides a summary of the distribution of the dataset. It displays key statistics such as median, quartiles, and potential outliers in a compact and easy to understand format. Box plot are particularly useful for comparing the distribution of different groups of or datasets. When we want to compare the distribution of different groups, or we want to compare the dataset, the distribution of the datasets, whether it is normal or not, whether it has some outlier or not, we can use the box plotting instead of histogram and other types of data. Here are the main components of a box plot. The box represent the interquartile range, IQR, which is the range between the first quartile and the third quartile. Basically, we have a box in a box plot, and it represent a box, a box with interquartile range. The height of the box indicate the spread of central 50% of the data. Line inside the box, there is a line inside the box. This line represent the median. It's mean quartile 2. If we know something about statistic, we know that if we calculate the quartile 2, we calculate the median of the data, which is the middle value when the data set is ordered. I need to off the mics. Just a minute. All right. Then there is a whisker. The whisker extend from the box to the minimum and maximum values within a specified range, typically 1.5 times the interquartile range. Value beyond the whiskers are considered potential outliers. If we have some whiskers and the value, some values beyond the outliers, some values beyond the whiskers are considered as potential outliers and are often plotted individually. So when we create a box plotting, we will identify some outliers which are outside the whiskers. I will let you know graphically which part of it I would consider the median, which part of it I would consider quartile 1, quartile 3, which part of it we consider as a whisker. Outliers. Individual data points beyond the whiskers are plotted as point to highlighted potential outliers. So when we identify the whiskers, we will also point out how much outliers in our data is. The next thing is the types of box plotting. What type of box plot we can create from our estimations from SPSS. We have three types of box plotting or box plotting data. Standard box plot, which represent the distribution of data including the median, the quartile, and potential outliers. Notch box plot includes a notch around the median, providing a visual aid for comparing groups. If you have a number of groups and you want to compare them using the box plotting, you can use the notch box plot. Then there is Violin plot, combines a box plot with a kernel density plot to show the probability density of the data at different values. This type of plot is basically used when you have some statistical probability in your data set and you would like to compare the data in terms of probability distribution. So the type of data that require box plotting, you may have numerical data. Box plot are ideal for visualizing the distribution of numerical data. So if you have continuous data or numerical data, box plotting is very ideal for identifying the numerical values, for identifying the outliers in numerical data. The second category for which the box plotting you can prepare is comparison of groups. When comparing the distribution of a numerical variable across different groups or categories. So if you want to compare your continuous variable with the different categories of other variables, you can have the type of data like comparison of groups. Then you can identify the outliers. You may have identification of the outliers using the box plotting. Why we prepare box plot? First purpose is visualization. Distribution box plot provide a visual summary of the distribution of the numerical data, like in bar charts, where we identify the distribution, whether it is symmetric, whether it is left skewed, or whether it is right skewed. In the same way, we can also find out the distribution of the data using box plotting. The next why we prepare the box plot, the next purpose is comparing the groups. When comparing the distribution of a variable between groups, box plot offer a quick visual comparison. The next one is outlier detection. Most of the researcher use box plotting to identify the outlier. So box plot are effective in identifying the outliers, which are data points significantly different from the rest. What does a box plot tell? It will let you know the central tendency. The median line in the box represent the central tendency of the data. It will provide you the spread of the data. The length of the box indicate the interquartile range, showing how spread the middle 50% of the data is. And then it will also let you know individual points beyond the whiskers of the box plot may be considered outliers, providing insight into the extreme values. So this is the visual representation in horizontal form of the box plot. Basically, when you see a box plot in SPSS, it will show you vertically. Here in the picture, it has been shown you horizontally to let you know what are the different parts of a box plot. The box is represented by IQR, which is interquartile range. And the first part of the box is called Q1. It is first quartile, which represent the 25% of the data. This is the point where there is minimum quartile. This is box. So after second quartile, it will become the 25% more. And after 25% more, it will become the third quartile, and this is the fourth quartile. So this middle value is called median. So this is how a box plot will represent. The next thing is how you interpret a box plot. In SPSS, it will look like this. This is the first quartile, this is the median, this is the third quartile. If you see, the median is away from the middle part of the data. And how we will interpret it, it is showing that 25% of the data are above quartile 3. You can see that 25% of the data are above quartile 3. In the box we find 50% of our data. This is the box. 50% of our data is in the box, and 25% of the data are below Q1. So this is quartile 1 basically. In quartile 3, the upper end of the box is the third quartile, the lower end of the box is the first quartile. When you see the box plotting in SPSS, you need to understand that the lower part is Q1, the middle part is median or Q2, and the upper part is Q3, and this is Q4. So you need to understand the box plotting different parts. Then how we can understand Whisker's point? You need to understand that point is lie Q1 minus 1.5 of the IQR. You need to find out the value of IQR. IQR represent this box. So when we multiply IQR with 1.5 of it, and we subtract this value from Q1, we find out the outliers of the data. So you can do it by doing it on the both sides, but in visual representation it is quite easy. So in case of a normal distribution, the IQR will represent like this. It will show the middle value in between, and it will show the equal distribution on both sides. All right, let's start from SPSS, how we can do it. Just go to the graph chart builder, click OK, and we have a box plot option over here. Just click it. And what type of data we can use? If we see, we can have numerical data, we can have comparison of groups, we can consider the categorical variable also. So you can have the categorical variable. For example, I have the gender, I have the age, education, and work experience as a categorical variable. If I would like to know the education as a categorical variable, I can create the box plotting like this. So simply click it. If I have a y-axis like gender, if we can take it, no, we cannot take y. Basically, we need a continuous variable over here. For example, if I may have the inflation, yes, inflation is a continuous variable, but we need to have BMS. All right, click OK, and you will see a box plot over here. No data to graph because all values of filter field have been excluded. Execution of this command stop. There are no valid cases. Statistic cannot be computed. All right. Analyze graph. We can see how we can perform it from legacy dialogues. Like here is the part. We need to create this simple legacy box. Yes. We need to have a continuous variable. For example, if we are using BMS as a dependent variable, and we have some categories from, for example, let's suppose we have age category as a categorical variable. Just click OK to see what will happen. Yes, it has created the box plot. You can see uh, there is no outliers existing. If outliers is here, it will be shown either the upper part or the down part. First of all, I will let you know this is Q1. The lower part is Q1. This part, this is Q1. The middle part is Q2, the upper part is Q3, and this is Q4. How can we interpret it? We can interpret that majority of data, 50% of the data lies in the middle part, and you can see that majority of data lies in the third. There is a small number of data that lies in the third quartile. So it is not normal, because it should look like the middle line should be exist in the middle part. So in all of these box plots, the middle line or median is not existing in the middle part. Same is the case that I have shown you over here. Like majority of data, if it lies beyond Q3, it will become smaller. The length of it will become smaller. If majority of the data lies in Q1, it will extend the line. If smaller number of data lies in Q4, it will be the smaller line. So you can see that in these cases the Q4 lines are smaller, while the Q1 line are larger. In case of 26 to 30 years, the Q1 and Q3 are little bit comparable, but still we do not have the median in the middle side of the data. So we can conclude that the data is not normal, because for a data to become a normal, the median line should be in the middle side of the data. So we can conclude here that our data for BMS in terms of different age categories is not normal. So we may have to make it normal. So this is all about today's session regarding the different types of graphs. We may have some more graphs, like you have 3D bars, you have area bars, you have high-low points, you have error bar, you have population pyramid. There are a lot of other options, but I need to discuss only the charts or the graphs which are frequently used by different researchers. So you personally can explore different options available, like in the bar charts, what options do you have? In the line charts, what options do you have? In the area bar, how you can use it? In high-low points, how can we use it? How high-low points are basically used in stock exchange, and in order to find out whether the currency is fluctuating the upward, downward. Then there are dual access points. There are a lot of options. You can simply explore these options. The portion that I have skipped today, like the stake bars or categorical bars, I will let you know tomorrow. But if you have any question, you can ask. If you have any question about today's session 1, session 2, session 3, you can ask. You can also analyze your data using these. You can check your variables by changing the categorical variable with different types of variable, and see whether your median lines comes in the middle of the variable or not. I also can compare, for example, I can compare it a variable with another variable. For example, if BMS is here and I would like to see ATM facility over here. No, it is not coming. It only works with categorical variable. I can change it. Yes. So you need to have a categorical variable on the other side. If it is not working, you can go to legacy dialog box and you can select this and define. You can change it. You can use education instead as a categorical variable and click OK. For box plotting, you should, there are no valid cases, statistic cannot be computed. Maybe they some cases are missing in that, so we can compute other. Previously we didn't have checked for this one. Let's see. Yes, it has computed it. You can still see the line is not in the middle, so there are some normality issue over here. For male, the data seems to be somewhat better. But for female, the data does not seem to be somewhat normal, because the first quartile is very much longer. It means most of the data points are in first quartile, while in case of male, the most of the data points are in the second and the third quartile. So we can say somewhat male respondent more responsibly the questionnaires, while the females have some responses may be incorrect. So this is what we can analyze from box plotting. You can also check it for another graph, another by creating another box plot graph. For example, we can check BMS rather than mobile banking. We can use mobile banking and we can check what are the finding of it. Again, here the male are more prominent in providing the responses. Majority of the responses from male lies between 3 to 4, between second and third quartile. So you can interpret it in this way. Uh, if your first quartile and your fourth quartile, they have the similar length, and it is in between with the same you can say the measurement, the your data would be normal. If they have different in length, as you can see in case of female, the first quartile length is very large, while in case of fourth quartile, the length is very low. So we can say the data or the responses from the female are not showing more normal, or you can say majority of the females responded either 3 or 4, and you can see the median number is in between 5 and 4. So we can say that majority of the female respondent either 4 or 5. In the same way, majority of the male respondent either 4 or 5, while most of their male data lies between 4 and 3. So this is how you can interpret your interquartile range. So if you have any question, you can ask, or any comment you want to suggest. And in tomorrow, we will discuss the comparison of different groups, like mean comparison for a single group, for two group, for more than two groups. That is, so if you would like to discuss anything, uh, let it be. If there is no question, please let me know, so I can conclude this session. Participants, I would like to know if there is a question regarding session 1, session 2, or session 3, please let me know. If there is no question, can I conclude? Please let me know. All right, sir, you can conclude. All right, let's meet tomorrow. We will discuss about group comparison, how mean or variance can be compared for a single group, for two group and for more than two groups, and that would be a very interesting topic, and you would love to hear about that topic. So thank you very much, dear participant, and be happy and be safe. Thank you very much.
Thank you, sir.
Welcome.
Thank you.
Welcome, welcome, Dr. Michael. We will meet tomorrow, inshallah.